Okay, so here are the three identical shapes that we 3D printed.
Yep.
And why don't you show how they fit together?
So it's just like the zone tool.
We can fit those two together, and then we fit this, and it looks like they don't want to stay together.
Maybe the whiteboard is too slippery.
Or what if I turn it?
Maybe.
Yay!
Oh, perfect. All right. Good job. Good job. Now take them apart a little bit. Now you noticed something very interesting when we were printing these shapes. What did you notice?
All of these layers are squares.
All the layers, well, we didn't measure them precisely, but they sure do look like squares.
Yeah,
right?
because this bottom layer is a square, and we're just getting, everything is scaling down up to this point.
Okay. So that's a very interesting thing to notice. Yeah. Another interesting thing about these shapes is we can know their volume. What is the volume of one of those shapes?
Well, so it's just the sum of the areas of all those squares.
Oh, okay, very good. Yes, yes, indeed. It's the sum, almost, because we have a little bit of thickness on this square.
Yeah.
So it's almost like they're tiny little like square boxes with very little height. So the volume would be all those together. We'll talk about that in a second.
We don't know how many squares there are.
Yeah, we don't know.
Well,
what's another way we could figure out the volume?
Well,
a different one.
If we say one of these sides is 1.
Yeah.
So the square has side length 1.
Yeah.
And you cut it into 3 pieces.
Okay.
So the volume of the square, the volume of the square is 1.
The what?
The volume of the cube is 1.
The volume of the cube is 1.
And so these are each a third. It's a third of the cube's area.
Very good. So each of them is a third.
cool.
Cool, right? So now, where I was going to go, but you guys actually went there first, is it seems like we sum up a bunch of squares, and we somehow end up with 1/3.
Hey, I think I've seen that before.
Have you?
If you write it in decimal form, 0.33333. If you say there's infinite squares, 3/10 plus 300ths plus 3/1000ths.
Okay.
If you say there's infinite squares, they'll eventually add up to 1/3.
But they don't.
That's interesting.
It
Those.
doesn't look like they have 1/10 of the area.
Yeah, that's actually a slightly different phenomenon, but that's an interesting observation that 0.333333 repeating is 1/3.
Yeah.
There's a different. It's a slightly different thing that happens here. We add up a bunch of squares and we get 1/3 of a cube, which is a little surprising.
Yeah.
And we will eventually study that a long time from now in a subject called calculus. But I'm going to show you, just for fun, where that comes from now. Okay?
Okay.